Good morning, good afternoon, good evening. Okay, this is Alexandra Aldama Henry Dianguken. Okay, so today we're gonna be talking about the bolting. Okay, bolt installation and inspection. All right, so this video is gonna be done in English instead of French. So I'm sorry. And for the English speaker, please give me a time to tell to the French speaker that this video is in English the entire time. Alright. Désolé, cette vidéo sera en anglais, ok, au lieu d'être en français. Ok, toutes les vidéos jusqu'à présent étaient en français. Celle-là est la seule que je vais faire en anglais parce qu'il y a trop de termes techniques que je ne connais pas en français et j'essayais de les rassembler, mais je n'y arrivais pas et puis donc j'ai décidé de faire la vidéo en anglais. Okay. All right. So this video will be in English. Okay. It's about bolting. Okay. This is the book. Okay. We call it the Bible of the Civil Engineering. Okay. It has everything about bolting, about structural steel, about any type of connection, and even the design and all the strength in there. Everybody knows it. Everybody who ever designed in a structure knows this book. Okay, when you talk about steel. All right. We're gonna be going. All right. So this video was made on Sunday, September 23rd. All right. So it's a video for the next week. Okay, I wanted to do one video a week. This video will be maybe long. All right, so we go now. So bolting, why we bolt and what we bolt. Okay, why are we bolting and what are we bolting? All right, so we are bolting, okay, because we want to connect members. All right, we cannot construct or we cannot build something like in one piece. All right, we need to go step by step. Okay, we need to make elements or members of the building or bridge or whatever we are building step by step and then connect them, okay, to progress in the construction. Okay, so when we need to connect them, we can connect them any way we want. We can connect them with welding, we can connect them with bolting, which is what we're doing right now. All right, so that's why we connect them. Now what are we connecting? We are connecting mainly the vertical member with the vertical member with horizontal member with horizontal member, and of course I already said vertical and horizontal together. So that's what we bolt. All right, that's what we connect. So this is an example of bolting. Okay, this one horizontal member here that stop here, and another one that start here and goes there. All right, and this plate here is used. This plate has its own holes, okay, and the existing plate here has its own holes as well, and we put this plate to be connected with that one here, and we put the bolt in there and we tie them. All right, so another example of what we bolt. So this one is a column, okay, which has a shop welded, okay, plate here, shop welded plate as well here, okay, with some holes, and then you insert the bolt in there and then you bolt it. Okay, sorry. Now this is another example, member here with some holes waiting for another member, okay, and with some holes as well. Put some plate holes, put the bolt in there, tie them, you're done. Now why are we bolting now? So before bolting, there was one technique called a rivet that was very old, up to not too long ago. So people were using that. If you go to New York City Transit, you go to all those stations, you're gonna see the steel has a lot of those steel up there have a lot of a rivet in there. So rivet has two heads, right? Instead of the bolting has like a head and a nut, okay, that you tie together. The rivet has two heads and it's very permanent, right? So you have one head that was shop made, okay, it was made in the shop, came like that. You put in the hole, and the other one is very hot, okay, very hot, and then you hit it, and then you make another head. So you have two heads, and that's it, and it's permanent. Okay, if there's a problem with the steel, you have to remove the the rivet that you put, work on the holes, reput it, and tight it again. And it's again almost it's permanent, and it's very work intensive. Okay, it's so we don't want that. We want to make sure that if there is something wrong, we can go back and fix it. Okay, so this is where the rivet here. Okay, this is a rivet here. This is a radiographic image of your rivet. So you can see inside the rivet what you have. This is the shop head. That's a head that was made in the shop when it was made, and when it comes to the field here, this part here, we make it very hot, and then we hit it, and then you have another head like that as well. Okay, but the bolt here, you see you have the head. This part here, the entire long part here is called the rod. Okay, so the rod is a bolt without the head. All right, and this is the nut. Okay, you can add to this one a washer, okay, which is a ring, okay, that you put there. So when you see this X, it means thread excluded. And what is a thread? On this rod here, there's one part that's like that, okay, with some ring around. It's called the threaded part, and this one is here is called the shank. Okay, so sorry, so the shank, all right, when you say X means thread excluded, so this part here, the thread is the weakest part in the bolt. So you don't want that in the ply. The ply is a limit between those two plates here. The two elements that you connect together, that you bolt at the border here, it's called the ply. All right, so we don't want this weakest part of the bolt to be in here, because this one move. You see, you have load here, you have load here, you have load in the bridge or the building that you have, so you have this movement all the time, and this part here is weak. You don't want that. Here, for instance, is N. N means thread included. That means if the thread is there, it's fine. The bolt is hard enough, it's okay. You can have it. Okay. All right. So here is still the rivet here. Okay, but you have two plates here that we call cover plate. Okay, here you don't have it. You have the two plate that you need to connect. You put the rivet in the middle, you're gone. Here, that's a two plate that you need to connect. Okay, they're horizontal, they're not overlapping, so you put overlapping on the top, overlapping on the bottom, and you do it too. Okay, so this is the bolt with different component. As I said here, that the thread, all right, they didn't talk about it here, but that's the thread. The entire thing here, from this one to this one, they call it the bolt length, but it's also the rod. Okay, and the head plus this bolt length here is called the bolt. All right, and here this ring here that you have here, okay, is a washer. Okay, and this one is a nut, is the one that you turn, right? You get inside the thread here and get inside, and then connect the two plates. All right, and this is the diameter from here to here. Is also from the outmost part of the thread here to the outmost part of the other thread as well there. So it's the bolt diameter. Same thing here, they just didn't put the head, so they call it also bottom head. Okay, that is the head, this nut, okay, this washer here, and that's a twist off one, and we'll know what we call twist off. There's a part here that twist, when you twist it, get off. Okay, all right, so we have three type of joint. Okay, so first of all, I have to define what is a joint. All right, a joint is I won't say connection, but the fact that you put two members together. Okay, you join them. You have one member, you have another member, you put them together, they're gonna be together. That's a joint. Okay, You have a T joint like that. When one member is like this, another one comes like this, that's a T joint. Okay, so the fact that you put two members together is a joint. All right, now you choose a method of connection to put those to have the joint to be stick together. Okay, to have the two members to be okay, to stick together, sorry. And there's three type of joint. Okay, you have the snug type. Okay, you have the pretension. Okay, pretension joint, and you have a slip critical, and each one of them need the previous one. Okay, and I'm coming. Snug tight means what? Snug tight means that you have two members. Okay, you put the bolt in the middle, you tied it. Okay, you tied it very strongly, and you can't remove it if you don't take, okay, a wrench. If you don't take a wrench, you can't remove the nut. You can't remove, you can untie it. Okay, and then also when you tie it, you need to have firm contact. Firm contact means that there is no gap in between. If the two members touch each other, there is no gap in between. That's firm contact. So if you have firm contact and you can't remove the nut if you don't use a wrench, that means you have attained the snug tie condition. So snug tie condition is needed for all those three type of joint. It's needed for snug tie, it's needed for pretension, is needed for slip critical. Okay. Now what is pretension? Pretension means that you bring the connection into the snug tie condition first. Once you have that in the snug tie condition, okay, what you do is that you have four type of pretensioning method, okay, to do to verify that you have achieved that pretensioning condition. That means you tie them again stronger than the snug tie condition, and we will see those four conditions. Okay, and slip critical is the same as pretensioning condition, but what happened is that with slip critical you have to work on a fairing surface. So what we call the ply is the limit, the border, or the connection, the when those two plates that you try to connect touch each other. Okay, my palm and this part of my skin here, this border here is the ply. Okay, where they touch each other is a ply. So on the ply you work on the surface, you clean it, you put some layers of product. So okay, and this ply is also called a fairing surface. So the fact to work on the fairing surfaces make the difference between a pretension and a slip critical, and that happens when you have cyclic load. So you have cyclic load, you have vibration, you have any type of vibration. Okay, it can come from earthquake, it can come from wind, it can come from any type of things or lateral load. You need slip critical. Okay, so snug tight used to have a definition before, like it's the tightness that is attained by the full effort of a man using a standard produce manner, and or by few impact of a wrench. So this definition was very debatable. So everybody was like arguing on that. So what is the few impact of a wrench? Like, is that or much more, or what is that? And full effort of a man, by men they mean human. So what is that? So I can have more strength than somebody else can have more strength than me, and what's the full impact is. So they change it. Okay, in 2009 they have another definition which is there. So the new definition is that the snug tight is the condition that exists when all the plies in a connection have been pulled into firm contact. And this firm contact is very important, because when the inspector comes, he checks if there's gap. If there's no gap, it's firm contact by the bolt in the joint, and all the bolt in the joint have been tightened sufficiently to prevent the removal of the nut without the use of a wrench. So that's what I was explaining here. Firm contact, no gap, all right? And if you don't use a wrench, you can't remove it. If you have those two conditions, that's it. That's snug tight, all right? Now, you have pretensioning condition. Okay, we talk about the three joint, okay, the three joint condition. So you have snug tight, you have pretensioning, and you have slip critical. Snug tight, it means you put the bolt, you tight it in firm contact, and you can't remove your hand, you can't remove anything else but a wrench. That's snug tight. After snug tight, we have pretension. Okay, if it's on pretension mode, that means you go above the snug tie. You put out the snug tie first, and then you have to tighten more. So you tighten more. You have four different ways of seeing if it's very tight. Okay, so the four different ways are turn off nut. So most of the time you're gonna hear me saying turn off the nut. Okay, I took this course in 2010 or 9, I forgot, when I did my steel design course. I was saying turn off the nut all the time. Teacher was saying is turn off nut, and it stayed. So turn off the nut, okay, calibrated wrench, DTI, and twist off method. So DTI means direct tension indicator, okay, and it's just a washer. It's just that type of ring that you put, like, but it's not a regular washer. It has bump, and we're gonna see that. And twist off was the second bolt that I show you, and that has the tail on the bottom. That's when you tie too much, the twist, you twist it too much, the tail get out, okay, gets twist off, okay. And you have the slip critical. So slip critical, you bring it to snug tight. After snug tight, you bring it to pretension condition, okay. But before that, in addition to that, you have to work on the fang surface. You have to work on the two surfaces that are going to attach to make the ply. So when working on those faces, like using like this this product that you put on it, okay, you make them tight better, so it doesn't, okay, it doesn't slip. And you get slip critical when you have load going in the direction of the bolt itself, okay. When you have it perpendicular to the bolt, you have bearing, okay. But when you have slip critical, it goes in the direction of the bolt, okay, and can make the bolt to slip, okay. That's why we want the surface to be worked on. We want everything to be worked on, okay, before you can we can have service on those members. So this is a turn of nut method, all right. And one thing with the field, when you work with a bolt, when you work with inspecting bolt and stuff, high-end workers, okay, all right, they're one of the smartest guy you can see out there, okay. They're very smart, okay, but I don't know if they're doing that on purpose, but sometimes they do things to piss you off, like you don't know where it's come from, all right. If you don't have to expect, actually, what can I say, you can't expect, you can't say that you know what the hiring worker is gonna do to you on the field, right? So it's when you inspect bolt, okay, it's a periodic inspection, all right. That means you don't have to be there the entire process. You don't have to be there when they put the bolt and do that. You don't have to be there the entire process. It's periodic. It's the opposite is continuous. Continuous means you're there when they start working until the last worker get out. Make sure that everything is fine. You do your report, you get out. But this one is continuous. Sorry, it's periodic, right? So what I suggest, or what I do, is that I make sure that I am there, okay, when they bring the bolt to a snug tight condition. All right, I don't want them to do anything, okay, until they decide to mark up. So I want to be there when they do the mark up, when they mark the bolt, and I want also to be there when they start turning, okay. You don't want to miss those three things. So this is how it works, the turn of the nut. When this one is brought in snug tight condition, okay, and you verify that there's no firm contact and all that, Okay, sorry, and you verify that there's no gap, there's firm contact. All right. What you come and do is that you observe them marking. So they put, or you can mark it yourself, depending on the project. So they mark here, they put one line here, one line on the bolt. So the two required lines are on the bolt and on the nut. Okay, so you put the mark on the bolt, you put the mark on the nut. Some people put also the mark on the plate itself. Okay, and it's not encouraged to do that. What is only required are those two two things: the plate, sorry, the bolt and the nut. All right, but here they put three. Okay, meaning that when you have those three aligned like that, it means that nothing has started yet. You're still in the snap tight condition. Here it means that you start turning. So when you do turn of the nut, even if it's turn of the nut, you can turn the nut and hold the bolt. Okay, what you want is the angle between the bolt and the nut. Okay, so if the bolt and the plate here are aligned, they're on the same line, that means what was turned was the nut. So when you put three line, it's good to know what you turn. This one should tell you that they turned the nut because the bolt and the plate are aligned, that those two didn't move. Okay, so the nut moved. So you have this line and this line this way. So you have this angle here. So how it goes, there is a table and they tell you that for this diameter of bolt, what is required to be done is 2/3 of a turn, 2/3 of a turn. Okay, so full turn is 360 degrees, so you have 2/3. That means 1/3 is 120, so you have two of that, you have 240 degrees. Okay, for instance, this one can be 1/3. Okay, so you have 1/3, you have 2/3, you have 5/6 of that. You have it depends on the table. So what is on the table based on the bolt, you read your table, you know how much they need to turn, right? So when they turn, you know how much they turn, right? So here is about 90 degrees. Okay, they turn here, from here to here. Okay, 90 degrees is from here to here. So they give a little bit of it. So it looks like 120. Okay, but there is a big tolerance. A tolerance of 30 degrees, tolerance of 45 degrees, tolerance. There's a tolerance for that. Okay, based on how much you need to turn. So everything's on the table. You don't need to read that by heart, but you need to know where you get it in that book. Sorry, in that book. All right. So you turn this one here. Okay, so you know that this one they have turned, this one they haven't turned. Okay, but why you want to be there when they do that? Because they might all be on the snug tide and they don't care. They just put a line here, put a line here, put a line here, and put one and one here, one and one here, one and one here. And you come back, finish your break or whatever, you take your time, you talk with whoever you want to talk on the phone, and then you come, you say, okay, this is that degree, this is how many degrees, this, okay, you guys are good, I'm gone. But this is not, this hasn't, reached the pretension. This was still snug tied. So they fool you and they're gone. They will never be responsible. You're gonna sign the report, you're gonna sign everything saying that you have observed it and everything was fine, and that's it. That's it. Okay, so you have to be careful. If there's turn off the nut, you have to be there for when they do the snug tie, for when they do the marking, and for when they turn it. Okay, you have to be there. You don't want to miss those three three things. Okay, sorry, I have when I finish to eat sometime I have those condition. So here this is a wrong, okay, this is a wrong marking. Okay, it's a wrong markup that they made here. So what happened here is that what is wrong, first of all, you have two marking on the plate. We don't encourage you to put two marking on the plate. And why people do two marking on the plate? First of all, you don't need one mark on the plate. You need mark on the nut, you need mark on the bolt. Okay, that's what you need. And I told you that when you put one mark on the plate, that can help you know if you turn the nut or if you turn the bolt, because you can turn the bolt, you can turn the nut, it's fine, but the markup has to be done on the nut side. Okay, now what's wrong with this one is two markup first. People do two markup on the plate. Why? Because they want to say that you start here and you finish here, and then I know that it's like 180 degree that you did. But one thing is that the mark on the nut, on the bolt here, is too long. It should be only half to know that you start from here, the center, to there to mark. But if you put a long one here, we don't know where you start. We don't know if you start from here and then turn to be here, or if you start this side here and then be here. We don't know that. And you mark also the nut wrong. You mark the nut here, you mark the nut twice. It's not acceptable. Okay, this is another wrong marking. Okay, because remember, three mark aligned like that means that you didn't start anything, unless you make a perfect full turn and come back here. This almost, I don't know who did that. That's not probable. Okay, so you have three mark here in the, everybody knows that you have three mark aligned here, like bam bam bam. We know that you didn't start. So how come you already have this mark here that people usually put as a second mark to say that's where you start, that's where you end, right? So you want to say you already mark it up here, maybe as a guide to say I'm gonna aim that, I'm gonna try to turn to come here, right? But if you turn and you stay here, for instance, how are we gonna know where you start? If you start here or if you start there, and if you start turning the nut and then the bolt, we don't know. That's wrong. You don't do that. And that's why you want to be there when they're marking, because when they mark up wrong, they mark up wrong. And there's something called pre-installation verification, where everybody is there, you show them how we're gonna be doing, how we're gonna reach the pretension side and all that. So this method is called turn of the nut. Okay, turn of nut. You turn the nut. Okay, and by the angle that you turn it, we know that you have reached the pretension. Now this is a calibrated wrench. We're not going to talk too much about calibrated wrench. Calibrated wrench is a very old method. People are still doing that now. We have new type of equipment, but this has to be calibrated every day, and you're gonna use that for, I mean, a lot of people don't use that, especially when they were using the torque wrench for doing it. Okay, now we have new equipment, so it can make sense to do it, but a lot of people don't use that. Okay, that gives you the tension directly, like when you use it, it gives you the tension, like it gives you the torque, and then they convert this torque in tension. But actually torque is not tension. You can achieve torque but not achieving tension. Okay, and that's one thing, and there's a big debate about that. So sometimes when they say that we need to do a pull test, for instance, for anchor bolt that is in there, to see if it still have tension, don't use a torque test to replace a pull test. We want to check tension, we don't want to check torque. All right, and some engineers just accept it, but torque is not tension, and there's no correlation. Even if there's a formula for that, for the installation of bolt. Okay, people made a lot of research, and a lot of engineers made a lot of research to show that they're not matching. Okay, it's not because you achieve that torque that you can relate to that tension. We're not sure if you attain that, if you have achieved it. So this one is called a shear wrench. Okay, and it gives you the shear. So what you have here is you can use that for for doing the calibrated wrench method. And here you have this one give you the angle at the same time when you start and when you stop. This one here also give you that angle. Okay, this one you use it usually for those bolt, I mean those twist off as well. Okay, and that when it press it, it's stop. You, I mean, you use that for any type of bolt. I'm sorry, any type of bolt you can use that. All right, and that's a calibrated wrench. All right. So now we're going to the twist off. Okay. So this is a twist off bolt. So this part here is a tail. So you remember that you have three type of joint. Okay. Of joint condition. You have snug tight, you have pretension, and then you have slip critical. Okay. If you want to use to check if a bolt has achieved its pretension condition, you can use turn of a nut that we just saw here, where you mark up and you see the angle, or you can use calibrated wrench, where you put the wrench in there, you turn, and that gives you directly the tension or the torque that you need to achieve, and then you can say, oh, I have achieved that number. Okay, some new equipment have the angle also on the bottom that you can try to relate. Okay, but here you have the twist off method, which is the third method. Okay, twist off method means what? It means that you put this wrench in there, all right, you turn it, and if it has achieved its pretension value, this one here, this tail here, get off. You get twisted and it get off. Okay, so when you have to check, and that's the easiest one possible. If I'm in a project, I want the engineer to accept that, because when you do the verification, you saw them doing the snug tight to check the gap. There's no gap. You check the fact that it's very tight. Okay, and when they go and trying to reach the pretension value, you saw that those tails were there before, and let's say the next day they want to do the pretension value. When they're gonna turn it, when you come, you see that you don't have those tails. So all those bolts that which don't have those tails means that those tails have been removed, so that those bolts have achieved their pretension value. So if they have achieved the pretension values, that's it. So you just observe it with your eyes, you know already that they're good. Okay, and this is the bolt. So I'm coming back here. You see here, this shank part, like the non-threaded portion here, is short. All right, and this one is long, but it depends, because it is in the hand here. You don't see that continuing here, right? So the head is right there. This shank here is very small. So this one, you can use it for things when for plies or connection, where we said like there's like N, it's like N or thread included, because you have the threaded part which is longer. But here you can have something where the shank here has some kind of length. Okay, so you put that, you turn it, it get twisted here and get out. So that is twist off method. So that's a normal twist off. You come here, you check, you saw that before those tail were there. Now you come, the tail have been gone. So no tail means that they get twisted and they get out, right? Sorry. Oh. All right. So I think here we're gonna check a video. Okay, and I might comment a little bit on that while we're doing that as well. What's going on? Video is gonna come. Okay, now they're gonna use the twist off method. Okay, so you have those plates that you want to connect. Okay, You want to connect the plate, so you have something that comes here and below, so you put them, you adjust them with the holes, whatever you need to connect. Okay, so you need to connect this plate here and this plate here, so those two on the top and bottom can be taken as that's a washer here, can be taken as a cover plate. Okay, so you put the washer and you put the bolt, and the head is on the bottom, so it doesn't need the head. What is good, you want to be on the nut side all the time. Okay, so we're gonna look at what he's doing. So he's gonna place all the bolt. Okay, and that's what the iron worker are doing, they place all the bolt. And when you do the twist off is one method, turn off the nut is another method. So you don't need to do twist off and turn off the nut. A lot of people still don't get it. They do twist off, they do turn off the nut. I mean, if you so want to do turn off the nut, why you approve twist off? Sometimes they just want to make sure that it turned, it get out, it get twisted and get out by achieving its pretension value, and it also verified the turn of the nut, like it wasn't because the tail was weak or something like that. But because of that, we do the pre-installation verification. So now it's turning to reach what? To reach the snug tight. So it's gonna turn until it can turn it again. You get the snug tight. Okay, that's what used to be defined as full effort of a man. Okay, so it turn, get the snug tight until you can turn again. That's snug tight. That's when you can't remove your hand and there's firm contact. So here there will be firm contact between the ply here. So I won't be able to see gap. I'm not talking about that gap here, but horizontal gap here. I won't be able. So now it goes to its pretension, like an additional turning, and then when the tail get out, that means you achieve it. So I'm gonna put a pause here and come back to it. Uh-oh. Okay, I'm gonna try to be where I was. Okay, where I was. Okay, I'm gonna put. Okay, I'm not gonna play with that. But when it turn, okay, the tail get out, right? It turn, the tail get out. It means it has been achieved. So I was there when it get to the snug tight, and I have to come here when it's turning, right? So for me, I'm sure that everything is good. But this is twist off. If I check that it was snug tight, I can come back later and just see that those things here have been removed. So if I have the picture when it reached the snug tight, and I have the picture when this one has been removed, based on the material itself that has been approved for this project, we know that when this thing is removed, it has reached its pretension value. So just by observation, we done with it. So I like twist off better than any other things. Okay, even if there is a DTI and squatter DTI. So this is twist off method, but this is a twist off that I don't understand. Why are you marking when you have twist off? A lot of people gonna say whatever they want to say, but if you choose twist off, you don't need to mark up. Okay, and you have marking here, here, and here. You want what? How many fraction of the turn? But it's twist off, man. It's twist off. All right. Okay. Now we have the DTI, which is the third method. Okay. The DTI is a direct tension indicator. Okay. it is a washer, okay, this type of ring that we put, but it's not a regular washer. This washer has some bump, okay, and those bump are called protrusions. Okay, if you hear somebody saying the protrusion, he's talking about the bump, okay, of the washer, all right, for the DTI, all right, and this is the condition where it gets to the snug tight, all right. You get to the snug tight, you stay, you leave it there. So if you use DTI, what happens is that there's something that we call the filler gauge. I'm going to show you that soon. Filler gauge is like something very thin, okay, steel equipment. It's I'll say tool, very small, and it's very thin, okay. There is a 0.005 and 0.015, okay, and you have to put it here, right here, here where there's the openings here. So if it enter here and touch the bolt here, it means we have an entry. If it can't enter here and touch the bolt, we have what you call a refusal. If you have a refusal, that means those ones have been flattened to a point where this one is touching the head of the bolt, and there is no gap enough, okay, to touch the bolt. So that means it has reached its pretension, okay. So you take your filler gauge, you put in there, right. If you have refusal, that means it has reached its pretension. But before you get to its pretension, you want to check if it has reached its snug tight condition. So to check its snug tight condition, you put it in there, you have to get at least some entries, okay. And if you get some entries in there, that means, and there's a table also for that, the number of maximal refusal you need to have to show that it's still on the snug tight. You don't have to do too much. If there is no entry and all is refusal, just as the snug tight, you have to remove the bolt and put it again and do it again. But here, when you finish the snug tight and show that everything has been snug tight, this is work intensive to me. You have to put filler gauge and all that. So when you come here and you put your filler gauge here and everything is good, I mean there is no entry, that means it has reached its I mean there's a table also for the minimum number of refusal. Here you have to look for maximum number of refusal, but here you have to look for minimum number of refusal, and there's a table for that. You don't need to learn that by heart. There's too much thing to know here. So what you need to know is where to get those tables in your book. That's it. So once you get those number of refusal, you're good. Me, what I'm doing is that I have this book here that's come from Bob Shaw. Everybody knows him. So here I have all my tables in there. It is in my pocket all the time. All right, I have all my tables in there, and whatever I'm looking for, I get it. Okay. Here, for instance, let me see if I can show you that. This is the number of turns that I need to have based on the bolt. Okay. So based on the bolt and bolt size and all that, I need, and I know if I have to take 1/2 of turn, okay, which is 180 degree, 2/3 of turn, which is 240, and 1/3 of turn, which is like 120 degrees. So I have that here all the time in my pocket. Okay, so you don't need to learn those things by heart. You do it for 10-15 years, you're gonna know it by heart one time. But me, for now, I just know where to find them. I get them and I check it. Okay, so this is what I was saying. This is the filler gauge here, enters here. So if you can enter here and touch the bolt here, you have an entry. Okay, so this is a filler gauge. You put it there, you can touch the bolt, you have an entry. If you put it there and you cannot touch the bolt, then you have a refusal. If you have a refusal, that means you have a certain number of refusal which is in your tables. That means you get it's good. You get a pretension. Okay. Now, we're talking now about something called the squatter DTI. So it's the same DTI, right? This is the DTI here, but this one is different because on the back, this is the front here on the right, and on the left you have the back. So on the back you have some silicone liquid here, right? So silicone, not liquid, but kind of it's cold material. So when you squeeze it, it squirts. Okay, it gets out from those openings that you have here, right? The silicone get out, so it squirts, right? So when it squirts, there's a volume of silicone that get out. So the more you press, the more there's a certain type of volume of silicone. So they're not all made the same time, the same way. So that's why you do your pretension pre-installation verification for DTI, and when it reach on the skid mold machine, you see the tension that need to have. When you reached it, you look at the volume of silicone that you have. You do it for 3 of them. Okay, you use 3 bolts of per length, per size, per length of the bolt, per size of the bolt, and per washer. Okay, that's a washer, for nut of the bolt, nut size of the bolt. And when you have that 333, okay, if there is only two type of bolts, so you're gonna have 6. No, you're gonna have three of those things, so 9, 9, 18, and then you do it. All right, and here, and you can only have one size of nut, for instance. Okay, and even if you have 2 size of whatever. So you have here the silicone, okay, and here you have the bent here, right? So when you squeeze it, you tight it, this one get out, okay, and squeeze. So this one example of that. So you have um you have the DTI, the squatter DTI. This is used here, that is used for this type of connection here. So the bolts are there, you have brought them to the snug tight condition, and then after you squeeze them, okay, to get the pretension value, and then you see that it squirts. So once you have that, you know already, all right, that you get, all right, to your pretension value. But you have, for instance, uh, here squirt here, squirt here, squirt of silicone, but none of that here, none of that somewhere else. So wherever you see you don't have the silicone there, you can try to put your feeler gauge and see if you have some refusal or entry. And there's a table also that give you the maximum number of entry here or the minimum number of refusal to know if it can be acceptable or not. If you have more refusal than what is said in your, or more entry than what is said in your table, that means it's not passing. So this one has to be redone. So this is what we call the schema. Okay, so that the Skidmore machine. So this Skidmore, okay, you use that for your pre-installation verification. So you put some bolt in there, as I said, 3 of the same length. Let's say there's 3 different lengths of bolt that need to be used. Like there's like 7 7/8 inch. There's 3/4. There's like, if there's 3/4 and 7/8, let's say 2, you're gonna have 3 of 7/8, 3 of 3/4 inch. If there are different size of depth of washer that need to be used, all right, you're gonna also use 3 of those. Okay, if there is 3 type of bolt length that need to be used, you're gonna also, if there's some type of length bolt that need to be used, you have to use 3 of each. And when you put all those bolts in this Skidmore machine, you put them in there, you squeeze them, you're trying to apply the torque, and once you apply the torque, this one give you the number, okay, and tension in kips, okay. And once you read that kips here, right, which is also in your table, you know that it's good. So everything needs to be good, and anything you choose, okay, there, okay. Minimum number of squirt, okay. For instance, this is the minimum number of squirt if you use the oh, I don't know if I can show you that. If you use the squatter DTI, okay, there's number of square that need to be there, and this is number of refusal, okay. This number of refusal, okay, based on the bolt diameter. All right. So if you use type 325 DTI, you want 2, all right, refusal, and that's minimum. If you use a 490, you want also 2, all right, and that's gonna be for your half an inch bolt. All right. All right. And for what we call 325 and 490, okay, those are grade of bolt, okay. There used to be ASTM bolt as well. ASTM is American Society of Testing and Material, okay. So any type of testing that we do in geotechnical, in structure, in any, they all come from ASTM, okay. So there's an ASTM number that show you the procedure how to conduct the test, or how the material itself has been made, okay. That's come from ASTM. All right. So before, they used to have ASTM A325 for the bolt grade A325 and ASTM A490 for the bolt grade A490. Now it's old, is no longer the case. So ASTM A490 and A325, they both combine now to be ASTM F3125. Okay, so new drawings now say ASTM F3125. Okay, and also is the same for the is the same for what? Okay, if ASTM F 1554 didn't change, that's the anchor bolt. Okay, that's the preferred material for anchor bolt. It's also the same for ASTM B633. So B633 is electroplate, okay, of steel. Okay, electroplate of steel. You do electro zinc, okay, instead of putting to paint the thing with the zinc, you do electroplate. Okay, now you have ASTM F 1549, okay, for that. All right. There's another ASTM. So when you have ASTM for when you have ASTM A563, okay, this is for bolt and nut. Okay, ASTM 563, for instance, does not do any of the washer. So washer is ASTM 436. Okay, so you're looking for washer is ASTM 436. All right, I'm trying to see if there is another ASTM that was obsolete that has been changed. So B633 to F1549, okay, if I'm not mistaken, and ASTM A490 and A325, both of them for ASTM F3125. Okay, all right. So if you see ASTM A490, that's an old ASTM, but it's still the grade of the bolt as well. Okay, all right. So thank you for following the video. All right, we couldn't talk about everything, where we talk about what we should be talking about, right? And if you have some question, you can ask. So one thing, we didn't talk about the slip critical, because it's exactly what the pretension is doing. Okay, it's a pretension condition. Everything we talk about the pretensioning condition is the same for the slip critical. The only thing is that with the slip critical, you have to work on the fang surface. Okay, fang surface is the same, the two surfaces that make the ply. Okay, The ply is when you connect the two faces before you put the bolt inside. All right, so thank you. All right, and God bless you. All right, bye.